All right, so hopefully you've got your notebook at home, your math notebook. If not, just jot this information down, these examples that we're going to do on like a sheet of lined paper, because you will need it for your classwork practice that you're going to do after this. So I am not going to glue in a new divider yet. Okay, we won't worry about that until we get back to school. But I'm going to flip to the last page that I have in my proportions unit. So the last page I had glued in was the page on discount. Just to the right of that, on an empty page, I am going to write equivalent proportions. This does still go along essentially with our proportions unit, but you will need to understand how to write a proportion different ways when we are working on our similar figures unit, which is what we're kind of leading into. So you'll have to be able to identify not only one way to write a proportion, but multiple ways. And we didn't focus on that with our proportions unit because I wanted to make sure you knew how to set up a proportion from a word problem. And if we set it up the same way every time, it's just a little bit easier and less confusing. But now we need to identify different ways to write the same proportion. So I'm going to start here with an easy fraction. And remember, a proportion is just two fractions set equal to each other. So I'm going to start with an easy fraction like 1/2. So I'm going to write 1/2, and I'm going to say that that would be equal to, you could come up with any fraction that would be equal to 1/2, but I'm going to use 5/10 for this example. So 1/2 equals 5/10. That's my original proportion I'm going to start with. Again, we will be using proportions to solve for a missing side of a shape in our similar figures unit, so you would have a variable involved and all that, but for right now we're just using numbers to keep it simple. So I'm going to kind of bubble this in because this is my starting point, okay? So I have 1/2 equals 5/10. Now I can write that a bunch of different ways. Maybe the easiest way to kind of look at this and say, well, I know I could flip that around and then be the same. Just like we did with our inequalities unit, we flipped inequalities around. We just had to make sure to change the inequality symbol. We don't have to change anything about our equal sign. If you flip an equal sign around, it's still an equal sign. So I think we could all kind of agree here that if I say 1/2 is equal to 5/10, I could also write that as 5/10 equals 1/2. I just flipped it left to right. So I flipped it like that. All right, now I'm going to look back at my original proportion that I had. I'm going to think, well, is there another way I can flip the numbers around? And I know what would be the same. If I have a ratio of 1 to 2, and I say that's equal to a ratio of 5 to 10, I could flip that entire thing upside down. And I could say that a ratio of 2 to 1 would then also be equal to a ratio of 10 to 5. Okay, now there's a couple ways that I can recognize that this is true. First of all, 2 over 1, I know that's the same as 2. If I just kind of think about like how I could simplify these fractions. And 10 over 5, well, that's the same as 10 divided by 5, which is also 2. Now there's another way, and I think this way is almost kind of easier, especially when you're dealing with multiple ways to move these numbers around. And this was flipping this from top to bottom, just so we can keep track of how we're doing this. The easiest way that I have found to kind of just check and make sure if the proportion is correctly rearranged is to look at your cross products. So we know that cross products are always going to be the same in a proportion, okay? If you don't get the same number when you cross multiply, that's not a true proportion. So I'm going to cross multiply 10 times 1. Well, of course, I'm just looking at my original proportion. If I cross multiply 10 times 1, of course, would give me 10, and 2 times 5 would give me 10. Okay, so that makes sense. We know that proportion is a true proportion. The ratios are equal. I could do the same thing over here, okay? If I were to take that 2 and multiply it by 5, that would give me 10. And if I were to take the 10 and multiply it times 1, that would give me 10. So I get 10 equals 10. My cross products are the same. Now, even though I have flipped this proportion completely upside down, my cross product should be the same. So if I multiply 5 times 2, I get 10. And 1 times 10, I get 10. All right, so I know I've correctly moved everything around. If you move the numbers around and you don't get the same cross products, you made a mistake. So there is one more combination that we can use, and that would be combining these two. So to not only flip left to right, but also up and down. So I'm going to kind of pick up with where I left off here, where I had flipped my proportion upside down, and then I'm also going to flip it left and right. So that would be 10 over 5 equals, let's make that an actual 5. So 10 over 5, and that would be equal to 2 over 1. So I have not only flipped this up and down, but I've also flipped it left to right. And even though I've done a whole bunch of moving around with these numbers, if I cross multiply and my cross products are the same, I know I've done it correctly. So 1 times 10, 10, 5 times 2, 10. I know I did it correctly. All right, and there is one more way that I can also set up these numbers for my proportion, moving them around a whole different way. So I have been comparing like numerator to denominator like this. I can also compare numerator to numerator and denominator to denominator. So I'm going to do that down here. So I can compare 1 to 5. So a ratio of 1 to 5, comparing the two numerators, I'm going to say would also be equal to a ratio of 2 to 10. Now, I know that this should make sense because 2/10 does simplify to 1/5. Those are true statements. I'm using these numbers that I had originally, but I am writing them in a different way to also make a true statement. Now, using the cross multiplication, I can still cross multiply and this still works. 10 times 1, 10. 5 times 2, 10. Again, this is looking at the relationship across the numerators and across the denominators. But it's another way that I could set up my proportion. All right, now that this is essentially my new starting point, I'm going to do the same thing. I'm going to flip things left to right. So if a ratio of 1 to 5 is equal to a ratio of 2 to 10, I could say 2 to 10 would then equal a ratio of 1 to 5. All I've done is flip my equation left to right. So I flip this left to right. And when I cross multiply, 5 times 2, 10, 10 times 1, 10. It works out. Again, using this as essentially my new starting point, I could flip top to bottom. So I could flip this upside down, numerator and denominator, and make this 5 over 1 is equal to 10 over 2. And that is flipping top to bottom. If I've done it correctly, my cross products will be the same. So 2 times 5, 10, 1 times 10, 10. It works out. And the final way that I could write this, using this new setup here, is to both flip vertically and horizontally and vertically, left to right and up and down. So I can take where I've left off here and I flipped it upside down. I'm now going to flip it left to right. So that would be 10 a ratio of 10 to 2 would be equal to a ratio of 5 to 1. And that I have flipped both up and down and left and right. When I cross multiply, same thing, I would get 10 equals 10. So we're just going to make a little note over to the side where you have some space along here, is that your cross products, when you cross multiply, your cross products will be the same. And in this case, my cross products were 10 each time. So I could say 10 equals 10 each time. The point of this is that if you have a question on a test where you have to set up a proportion in order to solve it, it's not asking you what the answer is, it's just asking how you set it up. You might set it up differently than the answer choices offer. So this allows you to figure out which answer choice would match what you have set up. And note there are 1, 2, 3, 4, 5, 6, 7, 8 different ways to write the same proportion. All right, I'm gonna slide this down and do another example with another fraction that might be easy to work with, because it'll be small numbers and you're familiar with it. So, and I'm going to kind of switch my colors here so things don't all mesh together. I'm going to use 2/3 as my next example. So I'm going to have 2/3, and I'm going to set that equal to any fraction that would be equal to that. Let's do 4/6. I know that these would be equal because 4/6 simplifies to 2/3, or 2 times 2 would give me 4, 3 times 2 would give me 6, or I can cross multiply and find the same thing. So if I were to cross multiply, 6 times 2 would give me 12, and 3 times 4 would also give me 12. So a few different ways that you can note that that is that those ratios or fractions are equivalent and you have a true proportion. All right, just like I did in the last example, I'm going to flip my equation left to right. So if I just flip everything around, I could say that 4/6 would be equal to 2/3. And all I have done here is flip it left to right. I can double check that I've done everything correctly by cross multiplying. So 3 times 4, 12, 6 times 2, 12. I've done it correctly. All right, next one, I'm going to go back to my original that I have. I'm going to flip it vertically up and down. So if I flip everything up and down, I could say that 3/2 would equal 6/4. And all I've done is flipped my numerators and denominators. Notice they were both proper fractions here, they were both improper fractions here. All right, cross multiply to check my work. 4 times 3, 12, 2 times 6, 12. And I'm going to do my combo here. So I'm going to pick up kind of where I left off here, where I flipped top and bottom. I'm then going to also flip-flop left and right. So I would say that 6/4 would be the same as 3/2. So again, that was a combination of flipping up and down and left to right. Check my cross products here. 2 times 6, 12, 4 times 3, 12. So I'm good. All right, here's where I get to compare my numerators together and make a ratio and compare my denominators to make another ratio. So you will be dealing with different fractions here because they'll be paired up differently. So I can say that 2 to 4 would be a ratio. So this is kind of my new starting point, looking at numerator to numerator. And I want to make sure to write that. If I go like left to right for the numerators, I have to go left to right for the denominators. You can't change and mix up your order. So 3 to 6 would be my other ratio. I know, just looking at this, both of these ratios would simplify to a half. Okay. This does not work left to right, where I could say 2 times what gives me 3. I mean, you could do it, but it wouldn't be a whole number. So you can either simplify your fractions to make sure they're the same, or cross products. Cross products, again, I think is just kind of the easiest go-to every time. So 6 times 2, 12, 4 times 3, 12. And that was not flipping anything around. That was just looking at numerator to numerator and denominator to denominator. I'm going to use this as my new starting point, and I'm going to flip left to right. So I'm just going to put the 3 over 6 on the left side of my equal sign and the 2 to 4 on the right side. So that was just flipping left to right from my new setup here. Cross products again would be 12 and 12. All right, I'm going to take this, again, this new original, and I'm going to flip it up and down. So 4 over 2 equals 6 over 3. Again, if I were to simplify these fractions, 4 over 2 or 4 divided by 2 would be 2. 6 over 3 or 6 divided by 3 would also be 2. What I've done here is I've flipped it up and down, and my cross products to double check would be 12 and 12. And the final way I can write this, again, the combo method, left and right and up and down. I'm going to pick up where I left off here and just flip my equation left to right. So I could write 6 to 3 equals 4 to 2. So that was up and down and left and right combined. Cross products, 2 times 6, 12, 3 times 4, 12. So the same concept applies to this example. Write this over to the side with this one as well. My cross products are the same. Or we can say equal. My cross products are equal. And in this case, it was 12 equals 12 each time. And there you have it.